Have you ever got up at midnight and tried to sneak your way into the kitchen for a late night snack, but by the time you got there, so was the rest of the family? Because of those squeaky floors. As soon as you started walking that way, the squeaks gave you away. Well, there's a lot of different ways to prevent a floor from squeaking, and the best way is to build it right to begin with. So if you're building a new home or remodeling, I can show you some ways to make sure your floor will never squeak. It all starts right below my feet right now with what's called an eye joist. Well, here below the second floor, you can see what's actually known as an eye joist. And the reason they call it an eye joist is because of its shape. It's got a cap on the bottom like an eye, and then our center long part just like the I in the alphabet, and then a cap on the top. Now the caps are actually laminated veneer lumber, and if you look real close, you can see the different striations in there. It's a lot of pieces of lumber glued together. That's the top and the bottom. Our center point is called oriented strand board, OSB, just like we wrap the exterior of the house with to add strength. Now the reason you use an eye joist like this is because this engineered wood will not warp back and forth. If we had a 2x12 like homes used to be built with, and some still are, and you had that solid piece of wood here, it's hard to keep the wood straight, and it can warp up or warp down a little bit. And then your decking is not going to be flat and level and smooth because the brace is not flat and level. So with the engineered wood that we've got here, we actually have a flat surface. This eye joist is made by Will Land, and a lot of different companies build them now. And they're great to have in your house because if you get your decking perfectly flat and attach it right, it's not going to squeak. A good way to test it if you're having a house built or remodel is try to stick a business card in there. If it's tight, that business card will not go in there. Here you can actually see a little bit of the glue is leaked out. That's a good thing to see. We got plenty of glue. This is a $1 million house they're building here, so they've got a really nice flooring system, and they did a cutaway for us so we could actually see how our floor decking comes together. You see, it's not just plywood nailed on top of our eye joist, it's actually tongue and groove. And you can see the tongue right here, and it slides into the groove of the other piece. I've got a quick sample here. Pulls apart like this, and one 4x8 sheet slides right into the other 4x8 sheet. So we've got a nice joint there. Now they don't just nail it or screw it in place, they also put glue all the way across the top of the eye joist. We saw some coming out before, and you can see it here on our cutaway where it's coming out. Put the glue all the way across, lay your decking on top of your plywood, slide it together, and then nail it or screw it in place. And remember, you got to hit the eye joist or it doesn't work. Now this decking's a little thicker than normal. This is actually 1 1/8 instead of 3/4 inch. Makes a little bit of a difference. Let's go downstairs and see why. Well, Georgia Pacific's helping us out with a little demonstration here. We've got concrete blocks at the end of 2 pieces of plywood, so it's 8 feet across. This is 3/4 inch decking that I'm on. That's 1 1/8. 1 1/8 is what we're using up in the house. When you move up and down on the 3/4 inch, you see quite a bit of flex in it. Now, the floor joists are not 8 feet apart. They're about every 12 inches, so you're not going to see that much flex. You can tell it has some motion in it. You get over here to the 1 1/8 inch, you can see it moves a little bit, but quite a bit less with the same amount of weight on it. Now, you put a floor joist every foot, and it's not going to move hardly at all. So we're going to have a flatter, stronger floor, which means that we're going to have less squeaks when we walk around. So if you want a good quality floor that's not going to squeak, there's just a few things to remember. Take a look at an engineered wood eye joist system to stop those squeaks. Make sure you put on thick decking, maybe even thicker than code requires. That the glue go all the way across the top of the eye joist, not just part of it, and that all nails or screws go through the decking and into the top of the eye joist, not beside it. It doesn't help if they're next to it. You do all that and you might be able to make it to the refrigerator at midnight without the family joining you. Today we're going to talk about one of the most important parts of your home, and that's the roof. It protects you and all of your belongings from the weather, but it also does a couple other things. And if you do it right, you can save a lot of money while you're building your home. Plus, you can really improve the design with just a few changes. Let's go ahead and get started. This house next door is a little further along, so we're going to use its roof line to describe a few different design elements that you might think about while you're building your house. And also consider the weather in your area. If you live up north where there's a lot of ice and snow, you want to go pretty steep with that roof because you want the weather to go straight off of it. If you live in California, you might have a flat roof. That's okay when it doesn't rain much, but if you get rain, it holds on that flat roof. So wherever it's ice and snow, go steep. If there's no ice or snow, you can go flat if that's the look that you're after. Now, roof pitch is determined by a ratio. It's called like a 12-12 roof or a 10-12 roof or a 3-12 roof. That's the pitch. We'll use this as an example. If this was a roof, and let's say it was a 4-12 pitch, That means for every 4 feet we went up, if we went across 12 feet, we'd hit the roof line. Now a 12-12 pitch would be much, much steeper. We go up 12 feet, over 12 feet, and there's our roof line. So the bigger the top number gets, like 12-12 as opposed to 10-12, the steeper it is. This roof line behind me, the gable on the front, that's very steep. That's a 12-12 pitch roof. Very nice as far as getting weather off. Not worried about the weather here, they're just using it as a design element. This piece along the side, that's not quite as steep. That's a 10-12 pitch. And again, it's just to determine the look of the house, or if you're in a weather area, you might need a steeper pitch. Over here on the other side of the house, they've done a couple interesting design things with the roof. Here you can see a turret that they've built, and it's actually round on the top. Now let me tell you, anytime you build with square lumber, it gets expensive when you build round, but on this house, it's really gonna look good once we're finished. Next to it, we have what's known as a dormer. Dormer is a part of the house that protrudes out onto the roof line and has a window. It allows a lot more light into the house, plus it also breaks up our roof line to add some design element to the roof itself. Once you go inside the house, you can see that there's a lot of bracing up there to hold your rafters in place. The reason for that is we're either gonna have a tile or concrete roof on this house. That tile and concrete is very heavy, so you really have to determine what you're gonna put on top of the roof before you build it and brace up accordingly. And as you can imagine, if you add more material, there's gonna be more expense. Now you can also see our decking right here from the inside. We looked at it from the street, but the decking looks a little different. That's because you can't see the wood from the inside. It's oriented strand board on the out, but it's actually a radiant barrier on the inside. This is Tech Shield. It's made by Louisiana Pacific, and what it is a radiant barrier. Now your attic can heat up to 140, 150 degrees in the summertime. What this radiant barrier does is the sun comes in and it actually hits this radiant barrier shield and the heat goes away, so you don't have heat gain coming into your attic. Instead of being 150 in the summertime, it might be 110, and that's gonna make a huge difference on your utility bills every month. Here we have a little example they've set up for us, and we've got a light bulb putting off heat in there, and then we have two roof lines. This first roof line actually has a heat of almost 100 degrees coming through there. Over here, we're approximately 70 degrees. So you can see it makes a big difference to have the radiant barrier in there. You might have seen the old style where they drag them and lay them on top of all your insulation, but the heat already gets into your attic and heats up your attic, and it just reflects it from your insulation. With this system, being on the decking itself, the heat won't even come into the attic envelope. So we're gonna have a cooler home. That means we're gonna have lower air conditioning bills. But one last thing, don't forget your rafter clips. These are only about $50 per house with labor. You put them from your top plate of your wall onto the rafter of your house. It keeps your roof on in a tornado or a hurricane. Very inexpensive, but very effective. Well, just to recap, when you're considering a roof, it's all about angles and pitches. And the steeper you go, the less the weather's going to affect it, but the more it's going to cost to build. Get your architect to play around with the design of your home, because just changing that roof a little bit will really change the look. Well, after the foundation, the most important part of your home is the framework itself. That's really the skeleton of your whole home. And it's especially important if you're ever in a tornado, a hurricane, or an earthquake. Now, when builders frame a house and you ever go up and grab the frame, you're going to find it's pretty flimsy. And a lot of times, the only way they attach it to the foundation is just with a nail popped in with a nail gun. You shouldn't be satisfied with that, because if there's ever a heavy wind, your wall just acts like a giant lever. As the wind blows against the wall of your house and the roof, you can see it pulls the nail right out of the foundation. Here on this house, they're doing it right, because before they ever started the first frame, they worked on the foundation. What they did was install an anchor bolt in the concrete while it was still wet. This anchor bolt is shaped like an L. It's down in the concrete like so. And then they drilled a hole in the bottom of the frame and set it over the bolts. You can see it right here. All we have to do is take a washer, put it on top, take a nut, bolt it down. Now, for a wind to knock this wall over, it's actually going to have to either break the bolts, which would be hard to do, pull it out of the concrete, which would be hard to do, or actually crack this 2x6 base plate that we have, which would also be hard to do. So it's going to take a lot more wind, probably 3 times the amount of wind, to take this apart as it would if it was just nailed in place. The next place we need to brace up is where our wall studs actually attach to the bottom plate, because that's where they can come apart in a high wind. We're bolted down on our bottom plate, and you can see it is green, so it's pressure treated even on this side. But here these wall studs are just nailed into it from the angles, and they were probably nailed from the bottom as well. But when that high wind hits the house, hits the walls and the roof, it's going to be pushing backwards. Our plate will stay bolted down, but here's where it'll come apart. To prevent that from happening, we go ahead and we wrap at least the corners with a solid sheet of wood. This is oriented strand board, OSB. This one happens to be made by Louisiana Pacific, but it's rated by the APA, the Engineered Wood Association. When you get into engineered wood like OSB, it normally has a rating. And you can see what it is actually just different layers and pieces of wood glued together, so it makes a very strong board. We've screwed it into the base plate, and then it's screwed into the wall studs as well. That way, for it to tear apart, it would actually have to shear these screws in half or rip all of this oriented strand board apart. So it can take a much, much higher wind before the house comes apart. And if you have the budget for it, go ahead and wrap the whole exterior of your house with oriented strand board. It'll be a much, much stronger home, almost like building a little tank. Now on the exterior walls, before we go up high and see the next place they can break, we look at how thick our wall studs are. A lot of people like to use 2x4s. I highly prefer a 2x6 exterior wall. It's 50% thicker, which means it's going to be a lot stronger home. Plus we can fit more insulation into it, so it's going to be quieter, and you're going to save money every month because it's going to be more energy efficient. Now, if you've ever watched a TV show about tornadoes, what's the first thing that comes apart on a house? It's the roof. Normally the wind hits the exterior of the house, it comes up, it grabs the overhang of your roof, flips the roof off the house, then the walls can't stand up, they just fall right over. Now the reason the roof comes off so easy is it's just really built for gravity. I mean, the rafters set on top, and they just stick nails down on both sides, actually just toenail it down on top. So if any pressure comes from the bottom, it just pops the nail right out. The way we prevent that is with what's called a rafter clip. Some people call them tornado clips or hurricane straps, but the proper name is a rafter clip. You can see we have one actually nailed in place here. We've got 5 nails here, and then we've got 4 nails here. For the roof to come off now, instead of just pushing these toenails up and out, it actually has to break these nails in half, or the wood has to just tear to pieces. So again, we can take about 3 times the normal amount of wind because we put these little clips on. And these are less than $20 for a whole house, material and labor. So why wouldn't you get these? Very, very inexpensive, and it will keep your roof on in a high wind. Before you build or remodel your next house, remember to specify rafter clips up on top of the walls, bolt or strap down the bottom of the walls, and corner brace at least, if not wrap the whole house in oriented strand board or in plywood to give a good, sturdy structure for a high wind or an earthquake. You do all this and it costs less than $500 on the average home. It's going to be safer and make your family happier. Spend the money now.